live in Austria, and if people think about this little tiny country in Europe, they mainly think about three things. They think about nature in the Alps. We have a lot of things there you can visit. People think about skiing, and people think about a third topic that's really a serious topic, very, very serious. People also think about Sacher cake, which is our typical dessert we have there. It was invented in Vienna, and it's highly associated with our country. And yeah, this is what this workshop is about. It's all about Austrian desserts. We will talk a lot about desserts. And besides this, we will talk about other topics, more boring topics like Angular and Signals, But mainly, it's about desserts. And I know I don't look that way, but I'm an expert in this field when it comes to Austrian desserts. So this is the first agenda point. We will move on with signals and computed signals. We will talk a lot about communicating with subcomponents in terms of input signals and model signals. We talk about change detection. We will even visualize how the change detection benefits from using signals. We go on with effects, when to use them, and more importantly, when to not use them. We talk about RxJS interop. Very important, because this gives you the best of both worlds. It gives you the simple way of working from signals and the powerful operators of RxJS and its observables. Things like switch map and debounce time and so on, things you very likely don't want to implement by yourself. Yeah, and then we also talk about stores, which is really the missing link in this story here. You really should have something like a store to establish a unidirectional data flow. The thing is, signals cannot really deal with asynchronicity, and that's why we need something else that is doing this asynchronous stuff for us, and this is where stores come in. And by the end, we will also introduce the ng-conf signal store, which is quite a new implementation, a very smart implementation, and a highly extensible one. Before we start, let me introduce myself. I'm Manfred. I'm a trainer and consultant for Angular, and I'm focusing on Angular in the enterprise. For this, I'm doing a lot of trainings and consulting. I'm also quite connected to the Angular community. As mentioned before, I live in Austria. I do a lot of stuff in Germany. On average, I'm there every second week, helping companies with Angular in the enterprise. And I'm always happy to work together with people around the globe, people in Europe, or perhaps people here in America. Okay, cool. So let's get started with the main topic. It's about desserts. And for this, I've prepared a little tiny demo application. Let's have a look into it. So this is my demo application. Not this here, but this here. And as you see, we see a lot of options for Austrian desserts. We not only have Sacher cake is fine, but honestly, you can do better when it comes to desserts. We see here always the original German name, which is Sachertorte when it comes to Sacher cake. We see a description and we can rate it. So yeah, Sacher cake is fine. We have apple pie. And here we have something that's very, very important. We call it Palatschinken, which is pancakes. I've looked it up because it's funny. The term Palatschinken is not used in Germany. It's only used in Austrian German. And I looked it up. It comes from Eastern Europe and it means cake, which is quite accurate if you ask me. And boy, this is really an awesome thing. Those palatschinken, those pancakes, good memories come up. Memories from my childhood where my grandma prepared them for me. Usually we eat them with jam, but you can do better. There is always one step further. You can do better. You can eat them with ice cream, which we call Eispalatschinken. Yeah, and this is really the best. And honestly, 5 stars out of 5 stars is too little. 5 stars out of 5 stars is not much for this, not much enough for this. And that's why I implemented a cheat mode. If I'm double-clicking this 5th star, then I can rate it up to 250 stars out of 5 stars. You know, when it comes to palatschinken pancake, math does not matter anymore. It's a whole different topic. Yeah, what can we do else? We can search by the English name. We can search by the original German name, and we can load expert ratings, which are my ratings, and then you get all those stars for ice palatschinken. And this shows if you come to Austria once, everything you need to know is to order some ice cream pancakes. Yeah, this is my example application we will use here, and that we will migrate to Signals. So the thing is, this here is meant to be an interactive workshop, and that's why you will get a lot of material in, let's say, 1 or 2 minutes. But before you get the material, the hyperlink pointing to all of this, let's talk a bit about it. On the first page on this website I will hand out to you, you have this hyperlink calling StackBlitz, and if you click on it, you get our example application loaded into your browser. It's a StackBlitz application that is basically some kind of Visual Studio Code or the underlying editor, and you have the source code here, and on the right you see it, you have the example application. This allows you to try out everything immediately without installing stuff. So the thing is, if you click this link here, this plus sign, you get a console in the editor in your browser, and this console is important for you because it allows you to deal with Git. They have integrated Git into the browser, and we need Git to check out all the branches for the different labs. I don't want to get anyone lost, and that's why we have 1 branch per lab, and at the beginning you just check out the right branch and you are on the right level to do everything. And you also need to reset everything you did before. This makes sure that the new branch does not collide with the code changes you did before. Otherwise, you might get a mess in this kind of the editor. You don't need to worry about resetting everything because everything is documented. You have a lot of branches in there. For each and every step, there is an own branch, and this assures you are ready to go with this or that lab. By the way, this website you will get in 1 or 2 minutes gives you a lot of hints how to get through all the labs. And sometimes you even see a diff like this, where we are removing traditional variables and where we are replacing them by signals. In this case, signals holding a string or an desert array. And you know, you can use those hints as is. Some people just copy them in. Some people look at them and then they hide them and then they try to do it by themselves. It's really up to you how you use this material. I think you know yourself best and you know how you learn best. Different people learn best in different ways, and I really want to facilitate all those ways with this material, and if you know how to use it, then you get most out of this workshop. At the end of the day, you have 4 options how you can attend this workshop. One option is to just watch me doing the live coding. And perhaps you make sure I'm not screwing up too much, because you know the human brain is a wonderful thing until you start coding in front of an audience. If you start coding in front of an audience, everything is stuck, and that's why I'm really happy I have that many quality managers sitting in front of me, so feel free to tell me if I'm messing up. So this is one option. Just watch the live coding, make sure I'm not messing up. Another option is you check out the solution branches and play around with them. Or you can do the labs later, everything is documented. Or you can do the labs now during live coding, and for this you can go through all this material you will get. So now let's have a look at the website, and then you will get the hyperlink. If we look at the website here, yeah, then we see it's loading. And we already see the best thing about this workshop on the first page. It's this button here, Get Started, and look at this. Hey! Yeah, so already because of this, the workshop already paid off. It's a lot of fun. I could do this the whole day. Actually, it took me the most time to find out what's the best animation for this. And here you see the Stack Blitz link. Usually I put this Stack Blitz to the right and the other thing to the left, and then I make it a bit smaller. And yeah, then we can go through all the steps here with all the hints we have. And yeah, after 1 or 2 minutes, you should see everything here on the right. Now my NPM packages are downloaded. This takes 1 or 2 minutes, but then we are ready to go. Awesome, yeah, and now I give you 1 or 2 minutes to start all of this, using this hyperlink here. So feel free to load the application in your browser. Please also bookmark this link because you will need it through the whole workshop. Who managed to download it? Please give me a sign. Okay, it's slow network connection. Okay, yeah. We will get there, and you can jump in at every time because we have all those branches. So you can let it download in the background, and I will talk a bit in between. I use Chrome. Honestly, I did not try it out with other browsers, but with Chrome it works for sure. Okay, so who started Stack Blitz so far without downloading the application and the libraries? Okay. Pardon? Oh yeah, yeah. Yeah, that's important, yeah. Okay, cool. Yeah, so let's start everything in the background, and in between we will use the time to talk a bit about signals and compute it. So, as you might know, signals are the new kid on the block. It's this brand new reactive primitive in Angular. And it's really a simple one. It's basically about an object holding a value, and a consumer can read this value. A consumer might be able to update the value, and after updating the value in some circumstances, we are notified. We are notified that something changed. And this is the foundation for accelerating change detection, because now Angular exactly knows, oh, there was a change, so I need to update my stuff there in the bottom right corner. And it's also key for our own reactive architecture, because now we can directly react upon a change and recalculate things, which makes sure that our UI is always up to date. If something changes here, everything can be updated in terms of logics, in terms of calculations, in all the other parts of the application. And this is what I want to show you in the first exercise. So if stack blitz hasn't been loaded, it's not a big deal. I will do it here in live coding. I'm just switching variables to signals. You can land back, and then you can just jump into the second exercise when everything is loaded. Okay, cool. So let's switch to my application, my desert application. Let's switch to the source code. And in here, we have a desert component. And this desert component, it's not this here. There's a desert component. And in here, we can get started with migrating everything to signals, which basically means everything that is currently a traditional variable, data bound to the template, becomes a signal. And for this, I'm going with the signal helper function. So as you see here, this helper function comes from Angular core, proving that this is really an integrated part of Angular itself. So let's import it. We have a signal with this initial value. By the way, a signal always has a value. This is a huge difference to an observable that might become the first value over time. But here, from the beginning, we have a value which seems to be a string. And this gives us a variable of the type writeable signal. To be more precise, writeable signal of string. So as the name implies, it's a signal we can update, we can write, and it holds a string. Not all signals are writable. We will see some read-only signals, and this is most of the times the case when we calculate something, or if we want to separate reading and writing. If you say, well, everyone is allowed to read my stuff, but not everyone is allowed to update my stuff, because I want to be sure it's only updated in a well-defined way. Okay, cool. So we do the same here. This is quite a mechanic task. And also there. Here we get, obviously, a writeable signal of Boolean. That's not a big surprise. And we do the same here. But when it comes to an array, we need some more type information, because otherwise we would get, you see it here, a writeable signal of never, which is not that much if we just get a writeable signal of never. The issue is the syntax here. Because of the brackets, TypeScript cannot infer which kind of array this is. It can be literally everything. It could be a deserts array, or a passenger array, or a Wiener Schnitzel array. It does not matter, and that's why we should provide some type information with this type parameter here. Yeah, a lot of special characters. Now we get a writeable signal of desert array. So the consequence of having a lot of signals is we need to call their getters and setters. To call their getters, we just use full parentheses. And to call their setters, we need to call .set. Yeah, and also this is quite a mechanical task, isn't it? Yeah, we need to get through this. I'm very sorry. By the way, here we have something that's special in this component. I really want to stress this out. Here we have a helper method. It also could be a function called doRated. And doRated takes a deserts array. It takes ratings, and it squeezes in those ratings in my deserts array. These ratings are from this nicely named type. It's one of the candidates for the longest type name of 224. But at the end of the day, this type is nothing else than a hash map, or as we say in JavaScript, an object, that is mapping the IDs of the deserts, like desert 7, to their ratings. Desert 7 might have 3 stars, and desert 8 might have 4 stars, and so on and so forth. So it's basically just a rating, and we need to squeeze it in somehow into our array. And for this, we are just mapping our deserts. You see it here. We are just mapping them. And if this desert is a part of my hash map, if its ID has a place in this hash map, then I'm cloning the desert and I'm updating the ratings with the value in the hash map, 7 stars, 4 stars, 3 stars, something like this. Otherwise, I'm just going with the desert as is. So this is how currently this functionality of loading the expert ratings work. And honestly, it's kind of a mess. It's kind of a mess for didactical reasons, because we need to remember to call this function time and again when we do something with ratings, like here. Here I have load ratings, and you see it here. After loading the ratings, I need to squeeze them into my deserts, and then I'm updating the rated deserts. And this is really not fun. It also is not local development in terms of when I'm dealing with ratings, I don't want to update deserts, I want to update ratings. So this is something we will for sure get rid of, and you will see how easy this becomes with Signals. We will do this in a minute. But for the time being, let's go on here. Let's just update here everything to Signals. We are calling the setter and the getter. And unfortunately, after loading the ratings, we need to mess around with the rated deserts and to update them. Another reason why this is not funny is we have to remember when this happens, we need to update it. When that happens, we need to update it. So for sure, there are better ways of doing this. Okay, cool. So here my component is now migrated over to Signals, which is quite nice. And we also need to do the same in the template. So let's switch to the template of this deserts component. And here we are lucky now, because we have Angular 17.3. With 17.2, we got two-way data bindings for Signals. That means we can stick with our good old ng model. We don't even need parentheses. To say the least, parentheses would be wrong here. So just use it as you are used to it, and Bob's your uncle. This is the case for two-way data bindings. When it comes to one-way data bindings, to property bindings, we need to call the getter. Also here, because we want to read the value and delegate it to this very property. Also here to show my loading indicator, and here in the for loop. Actually, calling the getter in a template is quite an important thing, because the template is a so-called reactive context. And there are basically just 3 reactive contexts in Angular. The template is one of it. We will see further ones in some minutes, but the template is one of the reactive contexts, and that means if we read a signal in here, the context will subscribe to the signal. So other than with observables, the subscription happens implicitly. We don't need to call .subscribe, no. Angular does this for us. We just need to call the getter here inside of an reactive context, inside of an template. Also here we need some parentheses. Saying this, the component here itself is not an reactive context. It is not. That means when I'm reading the signal here, there is no subscription set up for me. That means we always need to remember when we are in a reactive context and when not. And the first rule is the template is always such a context. Okay, cool. So I think I've migrated everything over to signals. I'm calling the getters and the setters. Let's ask the console, yeah, everything is green here. Green is a beautiful color. You know what it means. It means we can immediately ship it, put it into production. Oh, please don't do it. Please don't do it. And now let's try it here. Palatschinken and expert ratings, and hey, it works. So seems like our first step was successful. However, the thing is, you might wonder, what did we gain now? Because I explained a lot, we had some funny terms like reactive context, but at the end of the day, the application is still doing the same. So why is all this stress, this effort with signals? Well, basically, it gives us two advantages. The first advantage is we can improve our code and directly act upon a modification. And the second advantage is we can speed up change detection, because now Angular knows, hey, there on the bottom left corner something happens, I need to update the view. So here in the next exercise, I just want to do the first thing I've mentioned. I want to improve my source code. We stick with this branch. It's the next exercise in the same lab description. And now I will improve this ugly situation with the ratings. Because I really don't want to update my deserts after loading the ratings. And that's why I have an idea. And this idea is quite idiomatic in terms of going with an reactive system. I'm just introducing here a new signal. I'm calling it ratings. And it's a signal of desert ID to rating map, which is, as mentioned before, basically an object where the IDs of my deserts are mapped to the stars. Something like this. I don't want to go with cuckoo entries, and that's why I'm setting this here to an empty object. So this is the first thing we will do. The second thing is, as we now have ratings and deserts, no one prevents us from calculating rated deserts out of this. So let's do this. I have here rated deserts. And those are computed signal, or this is a computed signal. A computed signal that is calling this to rated, and I'm passing in, of course, the ratings. No, first of all the deserts, and then the ratings. And the thing is, computed is already the second so-called reactive context. That means if we call the getter of a signal inside of computed, computed will auto-subscribe to those signals and get notified when they are changed. And this ensures that everything is always up to date. When we update the ratings, everything is automatically recompilated, not recompilated, recalculated. And if we update the deserts, the same thing will happen. So we can be sure that we always have the newest version of the rated deserts. And this is also interesting from an architectural point of view, because quite often you need something like a view model that represents your data in a certain way. in exactly the way you need for this or that view. Sometimes you might just need the ratings, and sometimes you might just need the deserts, and sometimes you might need deserts with ratings, and sometimes you might need ratings with deserts. That means having a view model that really resembles how you look at your data in your component is something that's vital, and Computed really helps you to get such a view model, your representation of the data as you need it in your very use case. Okay, so besides this, everything we need to do is just to populate the rating signal after loading the ratings. And this leads to more streamlined code, because it's somehow more logical that after loading the ratings, to set the ratings and not to set the deserts. And hopefully that's it. If I did not screw up, that's it. So let's ask the console. Console says it's fine. Let's reload everything here. Balachinken, yeah, pancakes and expert ratings. Somehow I screwed up here. So let me double check what I did here. I'm setting the ratings. Oh yeah, I remember. I had the same issue in my stress rehearsal. I have this wonderful calculated rated desert signal, but of course I need to use it in my template. Yeah, this really helps if you use your variables in your templates. It's an old Angular developer trick. And then, hey, it works. It works, and yeah, the code is a bit more logically structured. It's something I don't need to be sad about. Awesome. So I have 3 architectural rules in this workshop. I will come up with them step by step. And we just saw the first architectural rules. If you architect a system based on signals, please derive state wherever possible. Use Computed for it. It is really not typical for a reactive system to update a lot of variables. When it comes to reactivity, functional programming, updating stuff, side effects is something we want to avoid. We really want to derive our state, and this leads to code like we have seen before, to code that is more beneficial for us. We can just do this in a synchronous way, because signals currently are intended for async stuff. And that's why we will introduce the store idea at the end of this workshop. Okay, cool. So let's talk about something that is possible since some weeks, namely input signals and model signals. Input signals and model signals allow us to send down a value to a child component and to use the value there as a signal, as something that's reactive, as something we can use together with Computed. Okay, so to be on the safe side, please remember to check out the right branch. I do it here. If you go with stack splits, you really need the reset, otherwise your modifications and the new branch are merged together, which is obviously not what we want to have. Forced checkout, this is what does not work in stack splits. Forced checkout, discard everything. Okay, awesome. So what we have here is a desert card component. And currently, this desert card has an input and an output. The input is a traditional input. It's a desert variable, a property we get from the outside, so that the card knows what to display. It's this portion of the page with the image and the description and the calories and the rating. And here we already see one of the drawbacks of Angular's traditional inputs, namely this input decorator does not give us any type information. That's why we need to have the type here. And that's why we need to say it's required twice. We need to tell it to Angular, hey, it's required. And we need to tell it to TypeScript, hey, it's required. It will always have a value. We do this with this exclamation mark, which is somehow not funny. We need to do it twice. So with the new signal-based API, it's more streamlined. We get rid of this here. And instead, I'm just calling input of desert. And that's it. I get my desert property to say the least, and you see it here. It's an input signal, which is a read-only signal mirroring the data I got from my property binding, mirroring the data the caller sent in. It's really read-only when it comes to input. And if we look more closely here, we see, well, it's actually an input signal of desert or undefined. And you know, undefined is always a bit special because we need to check for it with an if and we forget about it. And that's not funny. And that's why I want to go with, look here, dot required, which gives me a required input. So Angular will validate the call to this component and I get a hit on my finger if I'm not passing in the desert. And this gives me an input signal of desert. So now we can be sure that there is a value. When it comes to output, there is nothing about signals. An output is always an event. And as we will see during this workshop, signals are not suited for modeling events. Signals are suited for data that changes over time. They are not suited for modeling events. That's why the output will still be an event. However, to align the syntax, there is now also an output method, and also this one lives in Angular core. You see it here. And yeah, this makes sure our API is somehow synchronous. We have the same way of working on the left and on the right, which is quite important for a framework like Angular. Cool. So here I cannot set my ratings because my desert input signal is read-only. So I cannot deal with it, I cannot update it. But this does not matter in this very example. It does not matter because I'm sending the new rating to my parent, and hopefully the parent will update the rating, and then the new desert is sent down to my component here. So I will immediately get the desert with the new rating sent to the component again. However, if we want to succeed with this, the parent really needs to take care of updating the desert. And that's why I'm moving over to my deserts component. Here I have this updater, update rating, and in there I'm really updating the ratings I got from my child component. So this here is bound to an event handler of the child component, and it gets the ID of the desert and the new rating. And here I'm just updating my rating signal. For this I'm going with the update function, which is just syntax sugar. Instead of going with update, I could also get the ratings. Update it, update the value, and then set it again. So update is nothing more than this dance here, this choreography. However, it's a bit annoying to read something, to update it, to write it back, and that's why we have this update function that just takes the current value and projects it to the next value. So the simplest way of calling update is this here. It will not change a thing. It is projecting x to x, my ratings to my ratings. Nothing will change here. And for this reason, I go with this syntax. I update the ratings the ratings will be cloned. Spread operator ratings will clone them. That means I'm cloning all the ratings. All the ratings? Really all the ratings? No, not all the ratings, because a little rating in the north of France is reluctant. It will be set to this new value here. Who knows asterisks? Yeah, okay, cool, great. Okay, so this will be updated here. And also this example is a very important one because it shows that when going with signals, we should use immutables. This was a discussion in the Angular team, but they decided that for now, the contents of a signal should be immutable. Or to put it in another way, the object reference of everything that is changing needs to change too. Here the object reference of the whole ratings object is changing because we have curly curlies. That means we get a new object. Everything is copied over, and this guy within the object is also changing. This needs to be done by definition. And the reason of this is, sometimes it's not enough that the signal tells us I have been changed. Because sometimes the next question is, what has been changed? If this signal holds such an object, just knowing the object has been changed is not enough. We want to know where is this change. And if we have immutables, something that was quite usual in the Angular community for years, you think about on push and observables, if we have immutables, we can get this object and check just the object references to find out where is the change. Is the change here? Is it there? Just some simple checks for the reference. Yeah. So to cut a long story short, go with immutables. Okay, cool. So my desert card component emits the new rating. It goes up. Up there, the parent will update the rating and the desert comes down. And so my component should be up to date. It has the new desert with the new rating. And of course, we also need to call here the parentheses for my deserts because it's now, a signal. And one more time, this is quite a mechanical task. You could go with the good old if trick. Perhaps you know it, the good old if trick, where you have an artificial if that is just saying, well, let's check desert. Hopefully it's always truthy. And then we can say as desert. And so we can now use this desert variable in here. Do something with the desert or desert.description, something like this. This is a trick so that you just need to go with the parentheses once. You unwrap it once and then you use it inside this fake if. So this is a accepted workaround, but today we are at ng-conf, so no dirty tricks. We are playing by the rules. Let's do it in a very explicit way. Okay, what does the console say? It says green. I appreciate this. What does the browser say? Palatschinken, expert ratings, and Bob's your uncle. Awesome, cool. So we have seen that a subcomponent can communicate with us, and it can also get signals as a result of this communication. We have also seen that this input signal that might be required is always a read-only signal. However, sometimes we want to go with a two-way data binding. We want to read something and write it back to the parent, don't we? And this is what I want to show you in the rating component here. My rating component has a rating input and an output rating change. This is the typical pattern we have when modeling a two-way data binding. We have X and X change, Y and Y change, Z and Z change. This is really hard-coded in Angular. And because hard-coded is such a bad term, we call it by definition, don't we? By definition, we need to have rating and rating change to get the impression of a two-way data binding from the caller's perspective. And we could totally stick with this convention. It's also supported when we go with input and output. It will also lead to a possible two-way data binding. However, we can do better. Because one of the last minor versions of Angular 17.2 gave us model signals. And a model signal allows us to get rid of the output. And we exchange input by model. And now we can also say it's required or not. And perhaps we define the data type, which is a number. So the result of this is a model signal of number, and this is a signal we can update. Every time we update it here, the change will be propagated upwards to the parent so that the parent knows, okay, we have a new rating. Okay, cool. So this is quite straightforward. We are replacing 2 lines by just 1 line. However, and this now comes back to the idea of deriving state, this rating component is also a little mess. I'm very sorry, it's a little mess because of the cheating mode we have. You remember the double click that gives me 250 stars instead of 5 stars. And to allow for this, we have here some checks. If my actual rating is more than maximum rating, which is 5, I'm assuming this was rated in cheat mode, and so I'm switching over to cheat mode. Cheat mode means maximum ratings is max rating in cheat mode, which is, 500. I say 250, which is 500. And then I always need to remember that I have to call this method here, update stars, which gives me an array with booleans, true for a star that is selected, false for a star that is not selected. This is the second ugly thing. I always, after changing a thing, I always have to call update stars, which calls 2 stars to get the map with true, 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 false. So let's say I have something like this, true, 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 false. This would be a 4-star rating out of 5 stars. Also, this is ugly. We need to remember to call this guy diamond again. And we need to remember that we also do the same after entering cheat mode. This here is bound to my double click. Good point. Does the hashtag mean something? This is now the ECMAScript standard for something that's private. So you can stick with the private term keyword in TypeScript, or you can go with the hash map. This is the official ECMAScript standard, and the semantics are slightly different. Okay, cool. So to get rid of this update stars method, we need to call diamond again. Let's make this component fully reactive. And for this reason, I will also make max ratings a signal. I say it's signal. Let's import it. And stars is now a computed signal. And that's really cool, because now I don't have to remember to update my stars. They will be just recomputed when something is changing. So computed. And here let's call this punct 2 stars. And let's pass in the current rating. The current rating is a model signal, which can be used as a traditional signal. And let's pass in this dot max ratings, which is now a signal. So stars will always be up to date. We don't need to think about it anymore. So let's get rid of calling update stars. I really appreciate this. And then, of course, we need to make sure that we call the getters and the setters of our signals. So max rating is now a signal, so let's call the setter. Same here. We don't need to call an output anymore. We don't need to emit an event because we have a model signal. Changes are automatically propagated outwards. So let's get rid of this. And let's here call the setter. And this is really fun. If you look at the diff, you will see that suddenly this component has about half the code, and it's more logical, it's more readable. So for sure, a good thing. Let me double check if we need to update the template. Yeah, here we need to call the full parentheses, star of stars. Stars is now a so-called signal. And for my well-beings, I need to get rid of all those unused imports. Otherwise, my karma is destroyed. Delete all unused imports, and yeah, that should work. A default value for? Ah, yeah. So is it possible to set a default value for the model? Not if it is required. If it is not required, we can define a default model. And it's the same with input. Okay, cool. So, yeah, let's look if this works. Everything green, we all know what it means. Let's go here, and one more time, Palatschinken. That's the only Austrian term you need to remember. Export rating, and yeah, somehow we screwed up somewhere. So let me double check where I screwed up. So we have here, oh yeah, I'm doing the same mistakes as in my stress rehearsal. We need to call the getters here to have this comparison. Of course, it's a signal, we need to go with the getters. And one more time, Palatschinken, export ratings, and hey, Bob's your uncle. Nice. So one more time, we have seen signals, when used in a right way, really stream align your source code. Now let's talk about change detection. Signals can really improve your change detection. Was there a question? Yeah, actually that's a good point. So if you have signals, you can get completely rid of ng-on changes. Yeah, you can also refactor it to a version that does not need ng-on changes because the signal tells you if something is changing. Totally. Okay, cool. So let's talk about change detection. And for this, I'm starting with a really dirty trick. I'm using a dirty trick that allows us to visualize change detection in our browser. Let's make sure you have the right branch. Forced checkout, blah, blah, blah. And now let's go into our desert card. And in there, I'm adding a blink method. And because I want to hide the ugliness of this hack, I have a helper function. It's called inject cd blink. So we are using this for years to teach people about the change detection. And a good colleague of mine, Michael Eckert-Zickes, who is here somewhere, came up with the idea to hide everything that's a bit ugly underneath the carpet, underneath this helper function, inject cd blink, which stands for change detection blink. So, was there a question? CD is change detection, yeah. Change detection. Yeah. Okay, so let's go with this blink method. And let's data bind it here. This is the secret sauce, because if it is data bound, Angular will call it every time when Angular wants to know, was there a change in this component? And we will see by default, Angular quite often wants to know if something was changed. Look at this. Here I'm searching for new deserts, and for sure everything is blinking because I got new deserts. They need to be data bound. That's fine, that's fine. But look now, I start to type now, and on each and every keystroke, Angular checks everything for changes. And also, if I'm calling export ratings, you know, export ratings is just updating my ice cream pancakes. Everything is blinking.
Clarify, this is already using on-push change detection?
Not now, not now. We will introduce this in a second. So this is really, and that's a good question, this is really the default behavior of the change detection in Angular. Angular does not know if something changed somewhere. Angular just knows there was an event handler. Someone triggered an event handler, and Angular says, well, an event handler might lead to a change somewhere, might lead to it. But it does not know where the change is, and so by default, Angular is checking everything. Quite an eager, tiny guy, isn't it? But we can improve this here. We can switch to on-push mode here, also with signals, and in on-push mode, Angular can get notified about changes. Angular can land back and wait for getting the information that exactly here was a change. And yeah, this is nothing new. This already worked with the async pipe, I know. It already worked with observables, and now it also works with signals. There are even some little tiny optimizations for this when it comes to signals, but this would lead too far here. Let's just switch over to on-push for my desert card. On-push strategy, change detection strategy comes out of Angular core. And then let's move over to the deserts component, and let's do the same. Awesome. And now let's redo the example, and please keep in mind that our template is a reactive context. That means when reading the rated deserts, it gets subscribed to the signal, and so it can be notified when something inside of the signal is changing. Okay, let's search for deserts. Everything still blinks. That's okay because we load the data. It needs to be data bound somehow. But now look here. When I'm entering some criteria, nothing is blinking because Angular really knows that no change has affected our deserts. Smart guy. And when I'm clicking export ratings, look at this. This is really beautiful. Oh. Just the affected card is updated. I really appreciate this. Yeah?
Just verify. So even if you use signal over on push detection, still could not enjoy the wonderful detection savings to show.
Yeah, yeah. So the thing is, as you said correctly, you need to turn on push to get the performance advantages of signals. For now, perhaps in a year we will have something like a signal component, and if you mark your component to be a signal component, you might get this good behavior and very likely even more goodness for free. But for now, it's traditional code, and this also shows that the Angular team really takes care about a slow, gradual transition from the old world to the new world. No one is left behind. We can use our existing knowledge and move over little by little, and everything else that has been there before is still supported. It's a beautiful approach and necessary in the enterprise where we talk about long-lasting projects. Okay, so this is really cool if you ask me. On-push works with signals. So we have two benefits. We can work in a reactive way, our stuff is updated automatically, and the change detection also works in a reactive way now. Awesome, so let's talk about perhaps the most controversial topic in the world of signals, it's effects. Side effects that are always triggered when one of the signals are changing. For this, we need this branch here, 04, effect starter, to be on the safe side. And now let's go to the desserts component. We need a constructor. And here we can set up an effect. And at first glance, an effect really looks like computed. It is also a reactive context, the third one we are seeing, the third and the last one. And if I'm using a signal in there, the effect will auto-subscribe to the signal. So let's say we have original name in here. And let's say we have English name. So as we are reading the signal, the effect will subscribe to those signals, it's a reactive context, and the effect will be re-evaluated, re-executed every time one of those signals are changing. And what you see here is a first good usage of an effect. It's printing something out to the console for debugging reasons. Please remember to remove it after you have used it, but this is somehow really a good way of using effects because in general, and I even have a better way in a minute, an effect is for rendering stuff Angular is not capable of. Angular is not capable of rendering something to the browser console, to the JavaScript console. Or think about the toast message. Angular itself, by using data binding, is not capable of displaying a toast message. Or it is not capable of painting something to a canvas or to a canvas 3D. So all of this is a good usage of effects. It's always for the last mile between your component and the browser window where you need something to happen that is not done by data binding. This is the right usage of effects. Saying this, I want to show you a bad usage. I know we are at ng-conf and this means no dirty tricks, but I really have to show it to you so that you remember this anti-pattern. And we will also discuss why it's an anti-pattern, because just saying it's an anti-pattern is a bit cheap, isn't it? So something that you should not do inside of an effect is to propagate state. Write the English term over the original term, or something like this. Setting a signal, propagating state should not be done inside of an effect. And this for a very good reason. Because you want to avoid a situation where you change something here, and this leads to a change there, that leads to another change here, that is changing the first thing again, which leads to a cycle. So this is really a mess. It's really hard to maintain. And if you have a bug, a cycle, this cycle is hard to debug and to hunt down. So this is something you should avoid. And the Angular team tells us very softly that we should avoid it by slapping our face, by giving us here this error message that already says, hey, please don't set a signal inside of computed or inside of an effect. However, if you really have a good reason for propagating state with an effect, if you really have a good reason for setting an signal inside of an effect, you can turn off this, what I call child safety facility, by setting allow signal writes to true. In this case, you are allowed to do it, but in this case, you have to take the responsibility if it terribly goes wrong. And yeah, I don't want to be dogmatic about this. Sometimes something like this is really needed. But in general, you should try hard to avoid it so that you don't end up in cycles or code that works like a domino effect, you know, where one stone falls and brings all other stones to fall. In most cases, this here is used inside of libraries or frameworks. And then it's their responsibility to use it in a safe way, and you get a nice function to call that is always safe for you. Perhaps this is a good way for dealing with it. Yeah. Yeah, you can emit an output within an effect, that's fine. That's fine, and the Angular team with the last version added some code to make it more safe if you call an output within an effect. Yeah. This might be needed in some cases. Yeah. But when you just call an output, you don't need something like this, something like to allow signal writes. Yeah. So there are some, very welcome, there are some circumstances where this is okay-ish or where we don't look that closely, you know, we are all in project business, so sometimes it's okay, but in general, this should raise a discussion on each and every code review. But if you really need it, you can turn it on, and then you get this synchronization of the do fields. Okay, cool. Using effects, I can also show another very important principle of signals that really makes a difference between signals and observables. It's about glitch-freeness. What a term. Glitch-freeness. So signals are glitch-free in Angular. And what this means is something I want to show you with a little tiny experiment. Let's set original name to A and English name to B. And then let's do what each and every JavaScript developer is doing when they are desperate. They are calling set timeout. Yeah, it's quite often the last resort, isn't it? And yeah, here let's set original name to C. And English name to D. So what you might expect now is that you get an intermediate result in between here. An intermediate result because the original name has been changed from A to C. However, the English name is still B. It will change in a second, but it's still B, so you might expect such an intermediate result, and this is what is called a glitch in terms of signals. And honestly, you would get this glitch by definition with RxJS, with observables. You really expect something like this when you go with observables, because observables are event-based. They tell you, hey, something happened. And so you get the information, well, first of all, this was changed, and then the second part will change. This is as expected. Signals, no, observables are for events. If we talk about signals, they are not suited for events for a good reason. They are more suited for data that can change over time. And that's why signals are glitch-free. So you won't get this intermediate result if you go with signals. One reason is you don't want to trigger the change detection too often. So this here is nothing you would get with signals. Also, that here will be hidden from you when going with signals. I can prove you, if we look at the console, we have A, B, and then we have the second result, which is CD, but we don't have any intermediary results. So keep in mind, For this very reason, you don't use signals for events, you just use it for data that changes over time. Okay, there is another experiment. Let's use this questionable code here, and let's put it into ng-on-init. It won't work, because an effect needs an injection context. It fetches several services via dependency injection, and that's why this won't work. Also, Angular will tell you that effect can only be used within an injection context, which is, for instance, the constructor or a field initializer. If you really, really, really want to do something like this, call it in some other method, then you need to do the funniest thing that's possible in Angular. You need to inject the injector. That's really funny, isn't it? Injector equals inject injector. Yeah. Oh, yeah, and here, lowercase. Yeah, it's like a rabbit that pulls it out of the head of the wizard by itself. And yeah, we can delegate it here. Injector equals this. And then it works. You see, it works. The effect does its job. But normally you don't need this. I like to think about my effects and about all the other reactive stuff I'm setting up as cables of my house. All the wires I'm placing inside of the walls. I'm installing them when I build the house. When I purchase a new laptop, I don't install new wires. No, I just plug in the laptop into the socket, but I don't install new wires. And it's similar here. When building the house, you install the wires. When setting up your component, you are also setting up your reactive infrastructure, your wires that will propagate state from here to there. And then only signals are sent through those wires. That's why quite often you will use all this stuff here in the constructor or as a field initializer, as a rule of thumb. Okay, cool. So finally, let me show. So, now I get you, yeah. So the question is, and please correct me if I'm wrong, does the effect run too early when we call it in the constructor? And yeah, this was actually a good discussion in the Angular team, and we had this situation in the beginning. Meanwhile, we have some extra code in the framework that assures that the effect is not run before the component is initialized. So it's only run the first time after ng-init, give or take. And yeah, this solves a lot of issues, and yeah, it's very likely the right way to do. So thanks for this question. Okay, cool. So let me show you another very typical way of using an effect, because this is not. We've discussed this. And this is about calling a toast message every time something is changing. I have a toast service here, a very simple one. And let's say I want to say this desert's length, deserts loaded. So every time the amount of my deserts will change, I get this beautiful message that tells me, hey, you have now X, Y, Z deserts. This is also a good example for an effect because we are rendering stuff on the last mile between the component and the template. We are rendering stuff. Angular itself is not capable of rendering because it's a toast that is triggered via a service. C and D, yeah, let's get rid of C and D. This was an experiment. It was a lot of fun with you, but now let's get serious. Yeah, here we have it. 11 deserts loaded, and now let's search for Palatschinken and 2 deserts loaded with ice and without ice cream. Awesome. Yeah. One more time, please. Yeah. Yeah, totally. So I repeat this so that everyone hears it. What you said correctly is that the effect will also automatically subscribe to all the signals read in there, and so we are notified when it changes. And this makes the signal the third so-called reactive context we have. The template, computed, and effects, all they have this behavior. Okay, cool. This brings us to the second architectural rule. Yeah.
For effect, if I notice for any signal that's updated within an effect block, it will always run. So is it better to write different effect blocks for different signals if they are not related?
Yeah, that's a good idea. So if the signals are not related, use them in different effects so that not everything is all the time re-executed when just one of them is changing. Yeah, that's actually a good point. Yeah, and this brings us to our second architectural rule. Avoid effects propagating state and signal writes. Whenever possible, use computed instead, which is possible if it is synchronous. If it is not synchronous, we need the missing link, the store. We will look into it in some minutes. But before we do this, let's talk about an important topic. Let's talk about RxJS interoperability. Signals are very simple by intention. They are very simple, and the Angular team says, well, very likely they are good enough for most cases. But if you need a bit more, if you need the power of RxJS, you can get the best of both worlds. You can convert your signals over to observables, and you can convert your observables to signals. And this is what I want to show you now in the next lab. So one more time, we need to go with the right branch. Okay. And now I want to implement a type ahead. I really want to get rid of this search method. I want the system to automatically search when I'm typing something in. So I want to have a reactive behavior. And this is something that's not fully possible with signals. So let's convert our original name and our English name to the good old world of observables. For this, we need the namespace Angular core, so it's really an integrated part of Angular, / RxJS interop, and here we have some nice methods. Today we need to signal and do observable. This makes a signal out of an observable, and here we do it the other way around. Okay, cool. So, let's convert original name and English name. Original name $ equals to observable. And English name $ equals to observable. So, now we are in the powerful world of RxJS, and now we can do what we usually do with RxJS. We can use this here as our source observables and asynchronously map them to our result we need. I sometimes call them sync observables. and this is desserts dollar in our case. So desserts dollar is a combination, first and foremost, of original name and English name. Whenever one of them is changing, I want to get an information. For this, I'm using this newer overloading of combine latest. There's also an overloading taking an array, but then I have to remember the array indices. That's why I'm using this overloading where I'm assigning beautiful names. So I've combined both. Whenever one is changing, we get an information. And then let's pipe this through so that we get out our sync observable. First of all, I want to filter. My search criteria should have at least 3 characters for the English name or for the original name. Then let's do something we very likely don't want to do by hand. Let's debounce this data flow, debounce time. Let's debounce it for 300 milliseconds. That means if I don't do a thing for 300 milliseconds, then it starts to search for my desserts. I don't want to trigger a server call with each and every keystroke. And yeah, then we can go with deb. I know deb is not the most beautiful operator here. Some people really try to avoid it. I just use it for the sake of simplicity to set my loading signal. So I think if you do something that is also reactive, it's okay-ish, but in general, deb is something you should not overuse. I think we are at the core when it comes to this. And oops, in between, let's use something that's really powerful and something you don't want to rewrite by hand, as switch map. You know, switch map is really powerful because it gives you guarantees in terms of asynchronicity. It avoids race conditions. If you have overlapping requests, only the last request wins. So let's say, and very likely you know this, let's say you are searching for A, and then you say, no, I want to have B, and then you say, no, I want to have C. You are changing your criteria, and so you get overlapping requests. In the case of switch map, only C wins. Everything else will be aborted. And this is very likely what you want to have when searching via criteria. And besides switch map, there are other operators making sure you don't have race conditions in different ways with different strategies. Okay, switch map. I'm going with my criteria. I'm delegating to my desserts service. Find, I'm passing in my criteria, and then we will proceed with the result of find, which is a desserts array. That means I'm getting out an observable with a desserts array. And by the way, this here is one of the strategies you can use if you need to asynchronously derive state from a signal. I want to work with signals. That's why I'm converting back my desserts observable to a signal. This dot desserts dollar. So if we look now closely at the result here, we will see, yeah, it's now a signal again. A signal of desert array, that's fine. However, we also have or undefined. And undefined is always a bit bad because we need to take care of it, we need a separate if it's a mess. And perhaps you are wondering why we got undefined. The reason is a signal always has a value. By definition, it always has a value. However, an observable does not need to always have a value. Perhaps it takes 5 minutes until we get our first desserts. And so, by default, we get here undefined as a starting value. If you don't want to have an undefined starting value, assign here an initial value, and so you will directly start with an empty array, and after some milliseconds, you get the loaded desert. Yeah, now if you look here, we have signal of desert array, no undefined anymore. That's beautiful. By the way, as we are deriving state via computed, the remaining parts stay the same. And also this is beautiful. We don't need to deal with it. Everything is correctly derived with our former source code. Cool, so let's try it out. Oh, we have here an error. The setup, yeah. Of course, we don't need the search method anymore. And so we don't need to set our deserts. Let's get rid of it. Also, let's get rid of implementing on init. Because now the search is triggered when we enter something. F5, yeah, looks good. What do we have here? Oh yeah, the search button needs to be removed too. As mentioned, we don't need the button anymore, neither the button nor the search method, because search now takes place automatically. And if I'm entering some criteria, perhaps, I don't know, Palatschinken, then, hey, we get the result. How cool is that? Or sucker cake, sucker boss, and yeah, we get it. If we don't type in 3 characters at least, nothing will happen. It's filtered. But if we type in something like Torte, then yeah, we get 2 cakes, 2 Torten. Seems to work here. By the way, for the sake of simplicity, I'm not adding any error handling here, but please remember in real world, and you also have it in your script, you also need to take care of error handling because the observable will close down if there is an error. And then nothing will happen anymore by definition. So in real world, do something like this here, pipe, catch error, and then switch over to some replacement, which is here an empty array, and do something with the error. Here I'm just swallowing it, but normally you put it into a signal and then perhaps a toast message comes up. This is something that would be a nice extension to this example here, and you have it in your script. So please remember error handling, otherwise the whole observable is broken and nothing works anymore. Okay, so to make this a bit more beautiful, perhaps for my karma, we should add some initial parameters like Palatschinken, and then we start with some data. It looks a bit more beautiful. Okay, cool. Best of both worlds. By the way, I want to do another experiment showing you how powerful this integration between signals and observables is. And this also shows that because of all of this, even observables are better supported in the world of Angular. Let's move over to my experiment. Branch 6. And now let's go to a new component that's in there. It's my about component. It's quite an empty one and perfect for doing an experiment right in the constructor. I'm setting up a new observable. I'm calling it counter $. Interval observable that gives me a new value every second. Perhaps every second is better. And then let's convert it to counter signal. Counter $. Okay, so next step is we subscribe with our observable. and we print out the current counter. And then we do the same with the signal by going with an effect. And there is a little tiny difference you perhaps don't have really imagined. Of course, now we get two counters on the console. Let's go to About. Let's have a look to the console, and we see, yeah, it's counting up. When it comes to counting, JavaScript is really an awesome technology. But now let's move away to deserts. I'm leaving the route. And you see, my counter that is signal-based has stopped, but the observable-based counter goes on. My counter goes on. And this is the typical behavior of observables. We need to unsubscribe from them explicitly if we explicitly subscribe to them. And this does not happen, which leads to a memory leak sooner or later. So if I switch back and forth, bum, ba-dum, 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 I get a lot of counters here. And yeah, they are not closed and they consume memory and for sure CPU time. So to close such an observable, there are several patterns, but the Angular team gives us now a very simple way to get those semantics from signals. Just pipe it through the new operator that's called take until destroyed. This operator also lives in the Angular core RxJS interop package, take until destroyed. And yeah, this gives us the semantics of signals, which means this here will be automatically unsubscribed when the component is destroyed. The component, or to say the least, the current building block, the current service, the current directive, the current pipe. If I'm clicking here, yeah, everything stops. This shows two things. First of all, we can make our life easier with observables using this here. And the second thing is signals are quite implicitly when it comes to subscribing and unsubscribing. We are subscribing implicitly to them by reading them in an reactive context, and we get unsubscribed implicitly from them when the overreaching building block, for instance, component, is destroyed. Okay, cool. Now, pardon? The first output is, I think, here 0 or something like this, undefined, because a signal always has a value, and if we don't specify an initial value, we get undefined. It's because of this other difference between signals and observables. We always have a value. Yeah. So for a little amount of time, we don't have a counter value, and that's why we are starting here with undefined. Sorry for this. Okay, cool. So now we are really getting serious. Now we know everything. To really get serious, now we need to talk about stores. And stores, I already mentioned it, are really the missing piece of all of this. We need stores in some way to streamline our reactivity, to prevent that a change here leads to a change there, leads to another change here, leading to a first change over there, which causes a cycle, so we for sure want to avoid it. Or to say it in a different way, we want to avoid something I'm calling an incredible machine. Who knows this physics game from the 90s? Yeah, it really was a cool game. If I need to use terms from a software developer, I would say the utmost goal here was to produce a side effect. A side effect that causes something to happen, for instance here, that causes that this facility on the top right corner is started. So look here, I have an animation. The bowling ball goes down. It's triggering the cannon, which is triggering the balloon, and so on and so forth. Yeah, this was a lot of fun. Here we have a further example, and your goal was to produce this world so that you have an indirect side effect doing this or that. A lot of fun, but honestly, if your application looks like this, you really have an issue. If this is how your reactive behavior looks like, you really have an issue. And that's why we really need to stream align our source code somehow. And this can be done with a store. It does not matter which kind of store you are using. If you love Redux and ng-conf, stick with it. If you like another store, it's also fine. At the end of the day, this is just a technological choice, but the thing is you need a store, you need to tell the store your intention. You need to tell it what you want to happen. And I use the term intention here because this intention can be expressed in certain technical ways. If we think about Redux, the intention is expressed by dispatching an action. If we think about a lightweight store, this intention might be expressed by calling a method. Calling a method, telling the store, do this and do that. After expressing this intention, the store will do something for us, and this is the secret sauce. This is what signals currently are not capable of. The store will execute something that might be async, that might be asynchronous. It can be sync, but it might be asynchronous. And after that, the store might express the new state it got via a signal. And so the data flows down in a synchronous way, flows down into the component, into its template, and will be displayed by the data binding. And when we say it flows down, it can be projected using computed. We already did this. We can project it to our view models to get this or that representation of our data. And this really stream aligns your whole application. It makes it more clear. It makes it more predictable. You tell the store your intention, and you get some signals flowing down. And this is what I want to implement now in the next demonstration. For this, let's switch over to this branch. Force checkout, yeah, it's fine. And here now, I already have implemented a store for you because it's a lot of simple source code, and I'm quite sure you don't want me to watch this, to watch me to write this simple source code. And honestly, I don't want to write it either. That's why I've prepared it. Oh, my mic is going away. Seems like my ear is not fully compatible. Oh. Come on. So let me squeeze my ear through it. Yeah, life is really difficult if you are clumsy, you know. So I think you should hear me again, yeah. What do we have here? We have a store. It's a simple implementation. And you see I'm injecting my desert service for loading deserts. I'm injecting my rating service and my toast service. And all my state the store is managing is a private state. That's why I have those hashtag here that makes this variable private. And this is something you for sure want to have. You want to have a private state because not everyone should be capable of messing around with it. Everything here is private, but I'm projecting parts of it using computed to a public read-only property, a public read-only signal of string. It's read-only in two ways. It's read-only in terms of its object reference, so no one can override it. And it's also read-only in terms of lacking a set and an update function. It's not a writable signal, it's a signal because this is the result of computed. If you don't like this pattern, You could also go with a different pattern that looks about like this. You have a first signal, and then you derive a public read-only signal using as read-only, and also make the object reference read-only. This is another way of doing the same, of having a write-able private signal that is exposed as a public one. Okay, cool. So next step, we have here everything exported. We are computing our rated asserts, our derived data, and here I have some methods updating my state. And the first method is updating the filter. I use the update method of my state signal. I'm preserving all the state but the filter. And here I'm triggering a side effect, load deserts. I'm setting loading to true. I'm loading my deserts, and then I'm updating my state signal with this very desert here. Also loading is set to false. Yeah, this is what happens here. Okay, so the good thing is, as we now have this store, we can do async stuff, and also my component becomes simpler. If I move over to my deserts component, I can now get rid of all those services, hasta la vista, and I'm injecting my store. Desert store. And hey, now I'm delegating, yeah, this is now quite mechanical. Original name, English name, loading. This is quite a mechanical task, isn't it? Well, I think I don't even need deserts and ratings here in the component. All that matters is the rated deserts. So let's shrink this a bit, because we don't want to spend our YALF here, our YALF. Rated deserts. And now it's time to delegate all the methods. For instance, load deserts here, and also load deserts there. Perhaps I also need to delegate the filter to my store. So for this, I'm starting with a very simple approach. And this approach is about directly setting the filter or updating the filter, to say the least. We will find a better way in some seconds. And also here, yeah, as mentioned mechanically, I need to also load the ratings. It's just about delegating your code, which really shrinks down your component, doesn't it? And that's it. So everything should work as before, but now, oh yeah, it's more streamlined. No, we just need to talk about some further things, for instance, about the template. So let's go into the template here, the deserts component HTML. Now we cannot go with two-way data bindings. Yeah, this is one of the consequences, but it's a good consequence, because we want to have this unidirectional data flow. You remember, the intention goes up and the data comes down. And this does not really work together nicely with two-way data bindings. That's why we can replace this here with a one-way data binding. The data comes down. And somehow we need to find out when this data has been changed, when there was a change in the form, to propagate it upwards to the store. To tell our intention, hey, we want to have this updated to the store. And honestly, if I did not went with template-driven forms, but with reactive forms, this would be a piece of cake. Because a reactive form directly tells me, hey, I have been changed, and then I can delegate this value to the store. Here it's a bit more complicated, but as we all know, underneath template-driven forms, we have reactive forms. It's the same object model. And so we could think a simple directive that tells us, hey, this form has changed. And this is what I prepared here. I have a form update directive. By the way, the idea is something I borrowed from my friend Brecht Billier, who is a GDE in Belgium and who is dealing a lot with the topic forms in the area of signals. And he came up with such a directive telling us that a template-driven form was changed. So as you see here, this directive is implemented for the form deck. It gives me an output called update. And here I'm grabbing the ng-form directive, which is basically a wrapper around the reactive API of forms. This here is a wrapper around your form group that describes your form. And as you might know, a form group has value changes. We can subscribe to it. And when some value changes inside the form, we are emitting an output. And so we have the same effect as with reactive forms, but we can stick with template-driven forms. Saying this, there is nothing wrong with reactive forms. If you like them, use them, and then you don't have to think about this very issue. Okay, let's take this guy. Let's move over to the deserts component. Let's add it to our imports array. Let's get rid of unnecessary imports. And now let's move into the template. Here now we can use our directive app update. Let's call update filter with $event, which gives us an object with an original name property and an English name property. We also need to implement update filter somehow. Declare method. Yeah, I appreciate it, but not here. Let's move down a bit. Let's take our filter, which is a desert filter, and let's delegate it to our store. And that's it. Now we are sending our intentions upwards. The filter has changed, or we want to search now. We don't need this here anymore. And we are getting down our results in terms of a signal with a deserts array. So let's try it out. I want to have Palachinken. And here we go. So seems to work. Awesome. This brings us to the third architectural rule, namely stores make your reactive flow more manageable. And the thing is, I really tried it out. If you align with those three rules, your life will really become easier. Trust me. Go with those three rules, and your code will be more idiomatic. If you ignore those rules, it might work, but then you have a lot of side effects and a lot of cycles and a lot of signal writes you for sure want to avoid. Okay, I have a little bonus for you, the ng-X signal store. It's quite a new store. It's highly extensible and it's fully signal-based. Saying this, if you like the traditional ng-X store, it's fine. Stick with it. It already supports signals, you are safe. But if you say, well, Redux might be too much for my application, I would at least consider this very lightweight signal store. The thing is, at first glance, this signal store gives you a nice API for setting up a signal-based store. And it's very functional. Let me close this here for the explanations. It's very functional. You say signal store, and the result here is a service that is class-based. So you really get back a class from this function, and this service is already an empty store. And now you can augment it with your features. Features like with state, defining your state. Features like with computed, defining your computed signals. Or a feature like with methods, defining all the methods you need, like update filter, load deserts, and so on. So at first glance, it really looks like a class that has been tinkered in a functional way. A class that has been tinkered by calling those methods here. But as you will see in a minute, this really makes sense. Because now you can just add your very own features with the very own syntax, and so you can easily put your repeating code into such features. You could have an own feature like with CRUD, giving you a store for a CRUD use case. Just one line of code and Bob's your uncle. By the way, using this store works like before. We get a service with all those signals and methods and so on. And now, as the last example, I want to show you how an own feature could look like. Not this here, but this here. Look at this. Here I really use the possibility of the signal store, and you can look it up in the material how to do something like this. Here I use the extensibility mechanism of the signal store to write a with data service feature. And I just have to call this line of code here, and it gives me everything I need to connect a data service to my store, or to say the least, to implement a CRUD use case. Just this line of code gives me an entities signal with an array, gives me a load method, gives me an update filter method. And that means if you have the situation that you need to implement stores for similar use cases, CRUD use cases, other use cases, just put the implementation into such a custom feature and you can really nicely reuse it. So this is the true power of this architecture. And besides of that, we are getting signals from the store, something that really fits our story. As mentioned, more information can be found in the script you got in the beginning, but also in this free ebook. So if you like this workshop, download this free ebook. It meanwhile contains 4 chapters about the signal store. And yeah, it gives you everything you need on a textual basis with a lot of examples. So if you like the workshop, download it. If you did not like the workshop, download it either. Perhaps I'm better at writing than at speaking. And this brings us to our conclusion. So basically the conclusion is our 3 architectural rules. If you align with them, your life will be far easier. First rule is derive state wherever possible in a synchronous way. Use computed for this. The second rule is avoid effects propagating state and writing signals. And the third rule is use something like a store to streamline your reactive data flow, to have something like an unidirectional data flow. Here, one more time, we have the awesome graphic. And there's a last thing. Before you go, there is a last thing you should really remember. Please never, never, ever forget it. Namely, if you ever come to Austria, this is everything you need to know. Order some Eisballerschinken, ice cream pancakes. So thanks for having me. Thanks for joining. Here you have my contact data. And follow me on X on Twitter to stay in contact. Thank you.